It's been over 50 years since humans have traveled to the moon, but that's about to change. NASA's Artemis II mission is scheduled to launch on February 8th, 2026 at the earliest, depending on your time zone. Literally as I'm recording this, actually I saw that the mission has been delayed until at least March, due to some sort of hydrogen leak during tests just a few days before it was supposed to launch. So, this mission is the next step in NASA's Artemis program, a series of missions planning to not just return humans to the moon, but to eventually have settlements for extended stays. Artemis II is the follow-up to the successful mission Artemis I back in November of 2022, where an unmanned spacecraft did a flyby of the moon before returning to Earth. Artemis II will carry the first humans to the moon since 1972. The crew will include the first woman, the first person of color, and the first Canadian to make the trip to the moon. Though a crew is not set to land on the moon until Artemis III, set to take place in 2027 or 2028, Artemis II will once again be a flyby, this time with the crew, where they'll face about a 10-day trip there and back. The four-person crew consists of Commander Reed Wiseman, Pilot Victor Glover, Mission Specialist Christina Cope, and Mission Specialist Jeremy Hansen. The astronauts are set to lift off from Launch Pad 39B at the Kennedy Space Center in Florida. The crew will be on board the Orion spacecraft using the SLS, or Space Launch System. After lifting off and the rocket clears the launch pad, it begins a roll-pitch maneuver, setting its course for the trip ahead. Approximately 1 minute and 10 seconds after liftoff, the spacecraft will experience the most stress against it in a phase known as max Q. At approximately 2 minutes and 12 seconds, the solid rocket boosters separate, where they begin their descent back to Earth, landing in the ocean for their splashdown. The core stage and RS-25 engines continue to carry the crew away from Earth. After roughly 3 minutes, the protective fairings around the Orion service module are ejected, giving its solar arrays their first glimpse of the sun in space. 6 seconds later, the launch abort system is ejected. About 8 minutes in, the SLS core stage engines shut down, allowing the interim cryogenic propulsion stage, or ICPS, and the Orion spacecraft to separate from the core stage. Next, the 4 solar arrays of the Orion spacecraft deploy, giving the crew enough power to sustain the mission during times when the sunlight is not available. After orbiting for 90 minutes, the ICPS engine ignites to bring the spacecraft towards a high Earth orbit. The spacecraft and the crew will begin a thorough systems check that lasts nearly 24 hours, allowing the astronauts to adapt and settle into their home for the trip ahead. Upon reaching high Earth orbit, the Orion spacecraft separates from the upper stage rocket, where the crew can begin a manual handling test called the Proximity Operations Demonstration to ensure the craft is functioning and moving as it should, and to prepare future crews for docking and other future missions. Following the demonstration, a massive amount of data is collected to verify system performance. Approximately 23 hours later, the Orion service module performs the Trans-Lunar Injection Burn, or TLI, sending the crew on a roughly 4-day trip to the moon. The flight path is set to travel over 370,149 kilometers, or 230,000 miles from Earth. And during the journey to the moon, the astronauts will closely monitor the systems on board and practice emergency procedures such as testing the radiation shelter. The crew and craft will travel about 7,402 kilometers, or 4,600 miles beyond the moon. They will be the first humans to observe the far side of the moon in over 5 decades. The observations of Artemis II are sure to bring forth data that will help with future missions, updating our understanding of what it takes to send humans to the moon. While on the far side of the moon, the crew is expected to experience a communications blackout between the crew and mission control, leaving the crew isolated and unseen as they drift behind the moon. Once returning from the far side of the moon, the Orion spacecraft will set its course for Earth, drawn in by our planet's gravity, as it begins another 4-day trip back home. Before entering Earth's atmosphere, the Orion crew module separates from the service module. Thrusters on board ensure Orion is positioned correctly, at an altitude of approximately 121 kilometers, or 75 miles above Earth's surface. The spacecraft and crew enter the atmosphere, traveling nearly 40,234 kilometers per hour, or 25,000 miles per hour, where they will face G-forces 4 times more than they're used to on the surface. During this phase, crucial heat shields protecting Orion and the crew face temperatures around 2,760 degrees, or 5,000 degrees Fahrenheit, which is about half the heat of the sun's surface. To begin slowing the spacecraft, a series of 11 parachutes precisely begin deploying. Once the 3 main chutes are deployed at roughly 2,743 meters, or 9,000 feet, the spacecraft will be traveling approximately 209 kilometers per hour, or 130 miles per hour. The main chutes will slow the spacecraft to less than 32 kilometers per hour, or 20 miles per hour. The Orion spacecraft will splash down in the Pacific Ocean, about 93 kilometers, or 58 miles from the coast of California, roughly 16 minutes after entering Earth's atmosphere. A recovery team will collect the crew and spacecraft after their journey of over 1,101,940 kilometers, or 684,714 miles. This mission is just an overall good sign to see humanity once again pushing the boundaries a little bit, pushing outwards into our cosmic surroundings. It would be so nice to see more international collaborations where the best minds in the world can come together, as this is likely our best shot at true progression. The future of Artemis is bold. Artemis III is expected to see humans land on the moon once again, this time aiming for the unexplored lunar South Pole region. The journey of Artemis III is expected to be very similar to Artemis II. The Orion spacecraft will once again carry a crew to the moon and back, with similar launch systems as Artemis II. But once Orion is in lunar orbit, a Spacex landing system is expected to take the crew to the surface of the moon and back to Orion. Despite Artemis II's delay, the future of space travel is still exciting, and there's a number of interesting missions that have been proposed. We certainly live in interesting times, and I wish nothing but the best to the crew and all involved in the mission going forward. I'm very grateful to all the people who dedicate their time, energy, and lives to push these boundaries on missions like Artemis and others. So much respect and thank you to all of them. And thank you so much for watching today. I'd love to hear your thoughts on the Artemis program in the comments below. If you enjoyed this video, feel free to show your support with a like or by sharing this video with others. And if you'd like to see more videos like this and other space-related content, feel free to subscribe and hit the bell icon so you don't miss the next one. Thanks again. Until next time, take care and be well.